Welcome to All This Math. This is Professor Parker, and shout out to HBCU grads just because. All right. Now, today, we're going to talk about solving equations by factoring. Solving equations by factoring. All right. Now, in these two examples, we have two quadratic equations. I know that they're quadratic because the biggest exponent I see is a 2. All right. Biggest exponent I see is a 2 in both of these. I got x to the second power, and I got k to the second power. All right. Now, the first thing I want to do before I can factor is I have to put these in what's called standard form, which basically means that I have to move all the terms to the left side of the equal sign, and I should have a 0 all alone by itself on the right side. So this 3x has got to go. So the way I would do that is I would basically do the opposite of positive 3x, which is a negative 3x, or I could subtract 3x. So on your paper, you would write minus 3x, and then I subtract 3x from the like term on the other side, right? The like term on the other side. I can't take 3x away from 49. I can't take 3x away from x squared. I can only take 3x away from 17x. So be careful with that, right? So I write it underneath of the 17x. All right, that cancels out. Now I'm left with x squared plus 14x plus 49 equals 0. Now, this is a quadratic, and it's a trinomial. It's got 3 terms. 1, 2, 3. 3 terms, right? And it's a quadratic. So there's a specific way that we can factor these, okay? Now, what I like to do is I call this reverse FOIL method because my lead coefficient is a 1, right? Meaning this is 1x squared, and I can look for, and it's a quadratic and it's a trinomial. I can look for factors of 49 that add up to 14. Factors of 49 that add up to 14. That's one way to do it. There's another way to do it that some people watching this video might recognize because they might recognize that this is actually a perfect square trinomial. I don't want to really get into that right now, right? I want to focus on the reverse FOIL method. So the two factors of 49 that add up to 14 are 7 and 7. Because 7 times 7 equals 49, and 7 plus 7 equals 14. So what do we do with those 7s? We put them in the parentheses in the second spots. Because you got a first spot and a second spot. Or what we could call, since we're using it, we're referring to this as reverse FOIL, we might as well say this. First spot, last spot. First spot, last spot. Right? First, last. Right? Now, what goes in the first spot? The factors of x squared. The factors of x squared are just x. Because x times x equals x squared. So you put an x right here and an x right here. Now, these are our factors. Now, in order to solve an equation by factoring, the first step is to factor. We've done that part. We factored. Now we have to take each of the factors and create equations that are equal to 0 and then solve for x. So I do this. I take each of these, but actually I only have to do this once because they're the same factor. They're identical, right? So I only need to do this once. So I'm going to do x plus 7 equals 0. Now, that's a simple one-step equation. If x plus 7 equals 0, I just subtract 7 and subtract 7. Boom. X equals negative 7. Now, I only need to do this once because if I do it again with the same factor, I'm going to get the same answer. So x equals negative 7, right? Now, let's check our work. That means that negative 7 squared plus 17 times negative 7 plus 49 should equal 3 times negative 7, right? We always want to check our work. We want to verify that our work is correct. We want to verify that we know what we're doing. So over here, 3 times negative 7, negative 21, okay? Negative 7 squared, positive 49. 17 times negative 7, that's going to be negative something. 70 and 49 is going to be 119. And then plus 49. All right, so I got 49 minus 119 plus 49. You know what? I'm going to add these two together. That's going to be 80 plus 18. That's going to be 98. So then 98 minus 119. 98 minus 119 is 98 minus 119 is negative 21. And negative 21 does equal negative 21. So this is a true statement. Again, with math. In math and algebra or any area of math, we're looking for the truth. That's why we check our work. We check our work to see if this is true. Is it true that x equals negative 7? And by checking our work, we prove that that's true. We prove that it's true. Because we could just assume that it's true, but what if it's a lie? We want to know the truth. We want to get to the truth. That's the purpose of this mathematical exercise. We want to know what x is. What value of x is going to make this a true statement? -7. The left side should always equal the right side. Now, number 2. On to number 2. Again, our first step. Put this in standard form. It's not currently in standard form because there's no 0 on the right side. We want to move this -56. So what we're going to do is we're going to do plus 56 on the right, boom, and plus 56 on the left. Now you might be wondering, oh, but Professor Parker, you said that you got to only combine like terms. We can't actually add 15k plus 56. You're right, we cannot. I'm just writing it to show that we're going to add it to the left side, right? Because there's no constant on the left side. This is what's going to happen. This becomes 0, and then we're going to have k squared plus 15k plus 56 equals 0. So you see how we represent the addition of 15k plus 56, but we don't actually do it. Like in this one, we actually did 17x minus 3x because they were like terms. But here, these aren't like terms. So we can't actually do it. We can represent it, but we can't actually do it. Now, we got a quadratic, trinomial. So we're going to look at trying to do reverse FOIL. All right? Now, k squared. The factors of k squared are k and k. So I'm going to put the k right here, and I'm going to put another k right here. Now, what two factors of 56 have a sum of 15? Right? Not 56 times 1, because 56 plus 1 does not equal 15. Right? Not 28 times 2, because 28 plus 2 is 30, not 15. You need to know your multiplication facts. I can't stress that enough. In order to do this type of work, you need to have the fundamentals down. You need to know your multiplication facts. All right? The factors of 56 that work here are 7 and 8, because 7 times 8 is 56. And 7 plus 8 is 15. So I'm going to put the 7 right here, and I'm going to put the 8 right here. Now, if you're sitting at home wondering, well, does the 7 always have to go there and the 8 there? No. The order that the parentheses that the numbers are in does not matter. I could have just as likely or just as easily put the 8 in the first parentheses and put the 7 in the second. It would not have made a difference at all. All right? So now it's factored. That's our first goal. Our first goal is to factor the expression on the left side of the equation. That's our first goal. Then we're going to create equations, right? So then I'm going to do k plus 7 is one of my factors. So I'm going to make that equal 0, and then I'm going to solve for it. I'm going to do the same thing with k plus 8. I'm going to make k plus 8 equal 0, and then I'm going to solve for it. So then I'm going to have k plus 8. I'm sorry. This is k plus 7 equals 0. So I subtract 7 on both sides, and I get k equals -7. That's one of my answers. And then over here, subtract 8 on this side, I get k equals -8 for this answer as well. Now, I want to check my work. Make sure. So we check them one at a time, right? We don't put both solutions in the equation at once, because that's not going to work. We check them one at a time, right? So we say -7 squared plus 15 times -7, because we replace all the k's we see. Replace all the k's we see, which equals -56. Now, this is going to be 49. 15 times 7 is 70 and 35. That's 105, minus 105. Is this a true statement? Does this equal -56? And it does. 49 minus 105 is -56. If you got $49 in your checking account, you go out and buy something that costs $105, you overdrawn. You're overdrawn by $56. Your account's going to say -56, then your bank's probably going to hit you with an overdraft charge, probably like $40 on top of that $56. All right? So 49 minus 105 is -56. All right? So we're good here with this one. Now we got to know if -8 works. Does -8 work? -8 squared plus 15 times -8 equals -56. -8 squared, we got 64. 15 times -8, all right, that's going to be 80 plus 4, that's going to be 120. Minus 120 equals -56. 64, so that's 7 is 50. Yep, -56, same scenario. If you got $64 in your checking account and you go out and buy something that costs $120, you swipe, and you buy that thing, you make that purchase for $120, you're going to be overdrawn by $56. And then that bank going to hit you with an overdraft charge too. Probably another $40. So you're really going to be like negative $96 or $96 in the hole. You know what I'm saying? But listen, this is how we solve equations by factoring. This is one of the types of equations, or one of the types of factoring that we do that I call reverse FOIL method. Okay? All right, so I hope you learned something new. If you did, like the video, share the video, subscribe to the page if you haven't already. All right? And I'll see you on the next video. Peace.